Hello, I'm Sung Yoon. You are attending the class of CS588. It's about deep learning based image search. I'm Sung Yoon, the main instructor of this course. So before we talk about our lecture material, I'd like to talk about myself. I've actually worked on a lot on the image search and other related problems. So based on those experiences with my student, I'd like to talk about the image search and on other the computer vision techniques. If you're interested, you can check out some of my papers on video. Also, those videos are actually available in these links. So my main research theme is that I'm mainly working on designing intelligent and scalable techniques to efficiently handle large-scale data on the commodity hardware. So typically, I mainly work on this in the field of computer graphics. I mainly work on the forward reality rendering. In the field of this computer vision, I mainly work on this image search and other problem. Also, the motion planning robotics. But this course actually they're mainly related to this image search in the field of the computer vision. So I work with some of the people with Adobe and Naver and so on. This actually we actually had the result long time ago. This is an image search result. Basically, this query image, and then basically out of this about 11 million image, we actually spent only 35 milliseconds first with the single CPU thread to compute to identify the similar images from this given query out of this 11 billion image. Back then, actually, we used a very basic this image feature with the deep learning feature. But actually, obviously, there has been a lot of these advances in the field of this image search and many other techniques. I will talk about some of those the recent techniques. So also recently, the last year ICCB 23, we are also we actually released new benchmark, new image search benchmark. Basically, this is basically this benchmark. We actually name it as the pixel retrieval benchmark. So the prior image search technique is that given the query image, we identify similar image. But in this pixel retrieval benchmark, basically we identify the particular region that are matching with this particular region and part in the query image. So not just the image. Instead of just returning the similar image, we wanted to identify we wanted to highlight this particular region that are matching with the particular region in the query region in the query image. So you can check out some of this benchmark with this link. But basically, through this benchmark, we wanted to improve the granularity of the image search from the image level, this coarse image level, to the even this pixel level that actually that highlight a particular region. That way, we can actually we can help the user to identify the similar region more efficiently than the prior approach. I will talk about this technique more later on. So also there are many other related work that I work with my students. One is actually this person re-identification. Basically, we wanted to re-identify the particular person again and again with this image. So this is another applications of this image search. Another one is the optical flow through the matching. So to perform the image search, we need to perform this matching technique. But there are many other computer vision techniques that rely upon the very advanced technique of the matching. This is one example. Another one is that the visual inpainting. This is inpainting technique, but through the audio visual self supervision. So to do that, actually, we need to do another matching between the audio visual, multimodal. So basically, this actually multimodal, utilizing multimodal matching. Based on that, we do this video inpainting. So basically, my point is that there are many other related applications in the computer vision to the image search. This is my information. So I'm in the DCS building. This is my home page. So we will have the class on Monday, Wednesday, starting from 10:30. But this is actually offline course. But in this week, Monday, Wednesday, I will provide YouTube. I've noticed actually some of students didn't even know that actually this is actually first week of the new semester. So I will actually we actually starting this new semester too early. So I'd like to provide YouTube video only this week, Monday, Wednesday. But next Monday, let's get together at the class. This is our office hour. You can actually have a meeting right after the class time. Also, you can send the email to me. So this is the 2TA. So if you have any questions, you can actually ask your questions through the KLMS instead of sending email to the TA. So by sharing the activities, the questions at the KLMS, we can actually share those information within the class. In the class, we will mainly focus on the following things. We wish that I hope that you can understand you can have a broad understanding on the image and video search technique, also these related problems, and then I will lead you to deep into in-depth to get this in-depth knowledge on the recent techniques, and then also there will be the final project. So I will guide you with the TA to design better technology as your final project. So think about it. So basically in this course, you need to think about how we can actually utilize this matching and searching technique for many computer vision and many other related problems, including even your research and recently also there are many degeneration technique, AI, right? So you can even think about how we can actually apply those techniques to the recent AI techniques. So let me briefly talk about what's the main component of image search. Or some people say that this is actually content-based image retrieval, CVIR. But in short, in course, we will just call it as image search. So image search nothing but given the query image, we want to identify similar image from this DB from the database. Typically, we perform this image search from the web scale image database. So to do that, actually, we start from we are not just using the raw RGB the data pixel from the image. We typically extract the image. Before we have the deep learning, we typically use the SIFT, but obviously recent techniques actually we extract the deep learning feature like the CNN, and then actually there are lots of images here, but somehow we actually had a very fast data structure, so that we can efficiently extract a similar image feature, similar image feature, and also the similar imaging. That's the main process of image search. And also we can do the search in this case at Google with the text one. Obviously, there are also text-based search. But I can also provide my image. Then the Google actually can provide this kind of they can identify the home page that actually has exactly the same image, right? This actually identifying this duplicate image search. This actually one of the very simple cases of the image search. Early on, actually there has lots of technique that identify the exactly same image. Also, some people call it a duplicate image search. Also, there are many other applications of this image search and matching. There are lots of one. We can also do this Google. I'm not sure whether you are using the Google folder. I'm using the Google folder, and then Google actually identify the similar image and then group them, and then also we can do some search. Also, there are many cross-domain image search. We can start with this just painting, and then we can also given this query the image, also we can identify the similar query image, different types of painting. Also, we can start with the sketch, and then we can identify these kinds of painting. There are lots of techniques on cross-domain image search. Also, we can start with basically user can provide many different types. The text and sketch and so on. Obviously, we need to actually understand the user's mind and intention, and then provide some of the results. Also, this actually one of early technique that utilizing the image search component. So basically, there are actually some people actually provide this kind this program provides some sort of the simple UI. Basically they ask the user provide some sort of the color and some sort of brand and some type of the cloth, and then they can identify this kind of the cloth product. Also, one of my early students actually do some sort of this venture startup based on this image search, and then they move on to the other medical applications. another example of the product image search. Basically, by taking some sort of the photo, we want to identify these related product items given that taken photo. Also, we can actually apply this image search to the landmark location detection. We can actually take this query image and we want to identify the particular location. Obviously, if we have a GPS information, we can do that, but there are error cases. Sometimes actually we cannot have this GPS signal. At that case, we can actually have this kind of vision-based image search, landmark detection. By extending this kind of location detection, also we can do the 3D reconstruction. If we can take the larger photo on a particular landmark by collecting those kinds of the similar image, and then by actually out of this a set of 2D image, we can reconstruct the 3D information. This is actually one of the example of the image search. Also, in the field of robotics, we can also using the SLAM. SLAM is the simultaneous localization mapping. Nothing but we just out of this taken photo, same thing here, and then we actually from there we constructed this kind of 3D map, and then given the map, we want to localize the particular location of the robot within the map. So this actual robotic application of this kind of 3D reconstruction mapping, and then a particular application in the field of robotics, in this case localizing the robot itself within the map. Also there are many, if you perform this virtual reality, mixed reality, also we need to do this kind of application. But if you look at this kind of algorithm, basically you can see that there are many matching similarity the component that which actually main component the image search. Also, another one. This is actually one example of the object pose estimation, which also the server component also share large of the many components of image search. This another example, the transfiguring portrait. So given this input image, query image, and then we wanted to actually change its style to the other one. In this case, given input query with this input tag. In this case, I wanted to have the curly hair. And then based on that text, we identify the curly hair style, and then transfer this input image into that curly hair style that actually identified with this one. Then with this image, this actually given this text and the input image, we identify the curly hair style image. Then we transfer this content of the face into that style. So that's why we got this kind of one, this India style and so on. So this is actually this is not based on the recent generation technique, but also we can think about it. We can actually somehow combine this image search retrieval based approach, and then based on the retrieval result, we can also assist this recent the generation technique. This is another example of time-lapse photography and edit transfer. So we can identify similar locations with the different seasons, and then obviously we can change we can generate a certain video looking at the same location but with a different style. This is actually time-lapse photograph. You might heard about this one. We can also apply this kind of the image search techniques. Another application is for this person search, also VID. I talked about it early on. Given the query image contain this figure, a person, and then through the other video assistive, you identify the same person. This is actually positive image to the query. This is actually negative image. This is actually this is called person search or the VID. So I'm talking about basically there are lots of the components and applications that we can apply in the image search. That's not my own. I'm the only one who talk about that one. This actually I got it from some research in this Adobe people, and then they're also thinking about utilize once we have this very powerful image search, we can apply the image search technique to the other related problem like the image video recognition, segmentation, and so on. Also, I briefly talk about this issue. So recently, actually, there are many recent generation technique, this generative AI, but you know that actually it had some sort of the problems of the large scale language model. Basically, sometimes the result of the language model they had this incorrect information. We call it hallucination. But by retrieving some of the related problems, So there, we can actually we can search also retrieve relevant the website or the image that contain that given query image, and then we can also collect information from that website information, and then we can assist the generative process. This is called it retrieval augmented generation. I think that this actually I'd like to emphasize that this is kind of the new trend, new research trend that actually combine this combine the recent generative AI with the search technique retrieval. But I haven't seen this kind of technique a lot in the field of computer vision. This is very the novel direction, many coming from this natural language processing. But I wish that you can actually look at this kind of issue in the field of computer vision and image search. So here also let's get back to this Google search. Also the Google provides a visually similar image, but if I click this one, this actually identifies the visually similar. Some people say that it's visually similar to my image, but you can see that there are lots of room that we can improve further. Also it takes some time, so obviously we wanted to have a very fast technique that can search the similar image from the large scale web data. Obviously it takes a lot of the computation and infrastructure issues. Also if I basically this Eiffel Tower, also if I find this visually similar image, basically in this case for the very well known the landmark, Google actually identified very similar the image. But if I actually coming up with this from I got it from the China. This actually the very well known some sort of this Chinese landmark. But actually you can see that the similar image identified from the Google is not really correct. Because of that, the image actually has a very small landmark, but there are lots of the sky background, and then that's why actually the identify the similar image contain the large of this sky and some water, but it doesn't contain the actual this landmark. Obviously, you can see that we can actually we need to use some sort of attention mechanism here so that we can attend more on the important feature. There are lots of the topic that we can cover. We can start with the basic component, the image feature, and so on. We will talk about some component. But these are actually requisitive. Basically, I assume you actually have a basic knowledge on the linear algebra and data structure. Also, I assume that you know the basic knowledge on the machine learning, like the regression, also some of deep learning. I cannot talk about the low level machine learning, deep learning for this course. And also, I assume you actually have some prior experience on this programming, especially for the deep learning. If you're unclear, please send the email, or we can have the discussion out of this class. This is very important structure of this course. Basically, this is a research-oriented course. So half of during the whole semester, half of lecture will be given by me. Also, another half of lecture given by from you. So that way, actually, I'd like to lead you to identify some of recent paper, and then understand those recent one, and then based on that, I wish that you can conduct some sort of the project for your final project presentation. So this is what you need to do. You need to choose the paper and present them in the class, and then also I wish that you can propose some of the ideas that can improve these techniques. And then also we will have some sort of quiz and midterm and final term exam and so on. But the most important one is that I wish that you can have some fun by doing these kinds of activity. So this is a grading policy: 30% for the quiz, assignment, exam, 30% class attendance and presentation. The 40% is your final project. So basically, the class presentation project is the most important activity here. And then for when you are doing your paper presentation, also when you are doing your project presentation, basically me instructor, also the other fellow student in the class will evaluate your talk. So 50% of the evaluation coming from me, the 50% of the weight coming from your fellow students. So when you actually prepare your slide and presentation, you need to prepare them not for me, but for other fellow students. So basically, I wish that you can help each other so that we can understand better on the field of the computer vision and many other related fields. So basically, I think that you can actually you can have the 2 talks in this class, two talks for each student, and then present a paper in each talk. So basically, you need to identify 2 recent paper and then present them in the class. And then for this another further your final project, you need to actually, as I mentioned before, you need to go over some of the recent paper, and then you need to think about it. You need to think about what might be your final project, and then for that final project, I wish that you can actually propose some of ideas that can address these problems. They can address the problems of those techniques. Also, I wish that you can show some of benefit of your idea based on some of this implementation or the utilization of the existing code. So implementation of your idea is not really required, but it's recommended. Also, there are many existing codes, so I wish that you can actually identify the paper that comes with some sort of open source code, and then trying them, and then I hope that you can identify the problems, and then you can actually have a very simple, quick implementation that can show some of the benefit of your idea that can be done within this semester. Also, team project is allowed. I wish that you can actually identify some teammate, maybe 2 people in each team, and then you can actually work together, collaborate together toward the paper presentation, also the project presentation. We'll pick the best speaker or the best project award and then we might have the lunch with this awardee, with me or a TA, maybe at the end of after once this semester is done, and obviously higher grade will be given to the members of this best project. So I wish that you can spend more time for your paper presentation and then your project. That way, you can get the better grade, but that way also basically that way the other fellow students can learn more from your talks. There are some 2 programming assignments about the Bayes image search component. This is late policy, no score for the late submission. So basically, I recommend you need to submit your work, whatever they are, before the deadline. Also, there will be some of the 2 exams, midterm exam, cover the lecture material which will be given by me, and then also the very final term exam that will be covered the presentation material given by the students. Also, this actually also I'd like to encourage you to come up with some questions. So I wish you can come up with the 1 question in the class and submit the end of class. I will give you some score, but you don't need to worry about the score for your question. So I just give the 1 score for the typical question. But if you sometimes actually if you can come up with a very question with a software that surprised me or many people, that I can give you 2. But you don't need to come up. You don't need to try to come up with this kind of question. Just so ask the question that naturally coming to you. That's okay. And then you need to submit the question 3 times before the midterm exam. This kind of the question that you need to do. But I'd just encourage you to come up with the question. That's why I actually have this one. Another one is that basically you need to, in the end, you need to do the paper presentation and this also final project presentation. That way, I'd like to identify those papers. You need to actually go over recent paper on the image search, and then those papers should be from this top tier conference. And then every week you need to find the 2 paper and submit your summary before the beginning of this 1-day class. Also, the online submission is possible. So if you go to our class homepage, you can find this online submission site, and then basically you can. Obviously, I know that actually you cannot go over all the paper, understand everything, but just browse the paper, and then you can identify some of what are actually the recent topic that appear in some of the computer vision techniques. So let me use my laptop to go to the here online submission site. So this is our how can I do that? this is our home page. You can get the basic information. Also I had this some of the writer as a textbook, but actually this is it's very rough. Actually, I wanted to talk about some of the recent technology, but the recent technique moving so fast actually. But so that's why actually it contained some of the old technique, but not much on the recent technique. Also, there's some of this actually KLMS board. Also, here the question page. If you click this one, so you can submit some question 3 times before the midterm exam. So that way, I'd like to know what's actually the unclear to you. And this is actually paper summary submission before the Monday class. Even this week, actually, you need to identify the 2 paper, and then actually to provide some of the summary. Obviously, you don't need to. You should not copy the abstract of paper. Just browse the paper and then try to understand what's the main idea. And then you can provide this one. Just look at browse 2 paper and then provide these 2 summary before the next Monday class. We will get together in this class on next Monday. Also, since we will have the final project, so that's why I wish that you can have the team member. Once we get together, we'll talk about the team member here, and also obviously you need to keep thinking about what might be your team member. Basically, it might be too late if you think them later on. So basically, I recommend you to have some collaboration among the classmates, but assignment should be done by yourself, and then cite any other's work if you are using their code. This is actually the basic classroom etiquette. So this is a class attendance rule. If you are late 2 times, I will count it as 1 absence. If you actually every 2 absence, I will lower your grade. For example, if you got the A minor, if you actually absent 2 times, I have to lower down A minor to B plus. But actually, I wish that you don't have this downgrade based on this one. I will check your attendance in the class, and then if you're in a situation where you cannot attend or late, notify me earlier. This is some of the reference, my ongoing draft, but the PDF file is available at the web page, but it's very rough. And some other online available the textbook, also this basic computer vision book here. Also, there are many the paper, right? The technical paper, CBPR, ICCB, and so on. Also, there are many the YouTube computer vision resource and multimedia information other ones. So you can actually by browsing this one. Basically, the many this recent image search and related problems coming from the CBPR, ICCB, also the new RICS and so on. So you can actually check out some of top tier conference in the field of computer vision, also the machine learning. This is our course homepage. I actually went over this one. Also, if I get back to my homepage, class homepage again, we'll actually share some of the class slide, and then here, so you can actually check out the recent one. Also, the English is our official language, but sometimes actually, if you can follow some component, I may use the Korean. But whatever. In any cases, when I use the Korean, I will summarize them in English. You are not required to use the English, but sometimes you can use Korean to ask a question, but I recommend you to use the English. So this is my wish. I hope that you can follow up this lecture material and then this kind of various activity, homeworks, and I hope that this kind of activity can lead to your next publication or even this next startup. So far I talked about myself, this lecture material, but I'd like to know about you. Why don't you share your information, your name and email address, what's your major, and then your prior experience on the research on computer vision, your intention of taking this course as credit audit. you can provide this information by clicking this one. Let me do that here. If I click this one, it takes some time. Sometimes you lead to this form, but as you can see, sometimes there's some issue like this. Then you need to copy and paste that link. Say, if I actually copy the link, I don't have mouse, so it's just slow here. Then if I paste it here, this one. Basically, I wish that I actually wanted to know. I wanted to know more about you. Okay, so that's about it. And next time we'll talk about some of the basic components of this feature detection or the feature that many this image search technique that built upon. I will talk about this one next time. And that's it. Thanks so much. See you the Wednesday at this YouTube. Bye.